Hi. As was said, we're here to introduce to you the Longitude Prize on ALS, which is going to launch on June 25th. So please keep that date in your minds. I'm just going to explain firstly what Longitude Prize is and its origin story. And it dates back to the early part of the 18th century, where a big problem at that time was how do you measure longitude effectively at sea? Lots of brilliant people had tried to come up with a solution. Sir Isaac Newton, earlier Galileo, lots of people had tried and failed. And because you couldn't measure longitude at sea, it was incredibly dangerous and expensive to navigate the globe. And so a prize was launched, the first of its kind, called the Longitude Prize, for anyone who could develop a solution. Lots of innovators and scientists came up with all sorts of solutions which won awards, the sextant, improved star navigation, and so on. But the winning solution was the chronometer, which completely transformed the world and is a permanent exhibit at the Maritime Museum in London for anyone who's interested and is visiting London. So that's where the Longitude Prize began. More recently, the most recent Longitude Prize was awarded last year, and this was focused on antimicrobial resistance. And what we were looking for was a diagnostic that would prevent misuse of antibiotics, essentially. And this was won in the summer by a Swedish team who had developed a device, a point-of-care device, that will tell you in under 45 minutes if you have a bacterial or a viral infection, and if it's bacterial, exactly which antibiotic you need to take. And again, that is also on permanent display at the Science Museum in London, but hopefully you won't have to wait too long before you'll see it in clinic settings soon. Also a massive change. So we're coming up now to launching the next Longitude Prize on June 25th, and to explain the topic and the challenge that we're putting out there, I'm going to hand over to my colleague from Johns Hopkins, Jeff.
So what Trish is referring to is the prize is going to be focused on ALS, amyotrophic lateral sclerosis, or Lou Gehrig's disease, as we often refer to it in the United States. For those who are not familiar with this disease, this is an invariably fatal disease. The vast majority of patients only live about 2 to 4 years. And quite frankly, it's a horrible death. You die by suffocation, you lose the ability to breathe. In recent years, there's been enormous advances in understanding some of the biology that underlies ALS, but little translation of that into effective therapies. It's a complex disease, quite frankly, not unlike that of Parkinson's or Alzheimer's. And as a class, these are referred to as adult onset neurodegenerative diseases. And there's a lot of overlap between these diseases in terms of some of their mechanisms. Because of that science, there's a real opportunity to develop new therapeutics if we can integrate all of that science properly. And to date, we quite frankly, since I'm in that area, have quite frankly failed largely at it. And we think now there's a convergence of both large amounts of science and patient data and the ability of tools like AI to change that direction. So the potential for AI, I don't have to tell this audience, is really quite great. One, we really have a lot of data about the disease, and there's an example where we can make that difference. There's a rare genetic form of ALS. It's based on a rare mutation, and by using gene therapies, we can turn off that gene. In those rare subset of patients, repairing that gene, those patients aren't dying. They're living years longer, and actually 50% of them are actually regaining strength, because it's a disease that robs you of your muscle strength. So it's clear that if we understand the pathways and develop effective therapies, we can make a difference. AI is clearly a tool that can advance our understanding of both the biology and then help us develop new drugs. And that's an important opportunity for us. The other part of this is to do AI properly. And to be fair, I am not an AI scientist, but I do know a lot about data. And we're now at the forefront of having large amounts of data. They're accessible. You heard about open source at the beginning of this. Most of this data is largely open source. It's available. and to take advantage of those large sets of data. And we think ALS is a prime candidate to take the data. It's a multidimensional disease. There's clearly probably subsets, and use the data, identify the subsets, and eventually come up with new therapeutics for them. So what is really that data? So today, there's a worldwide abundance of data coming from multiple investigations, largely academic, around the world. And this prize is oriented towards aggregating all of that data, making it available. And this pie chart shows some of that data already currently under wraps for use in this project. Answer ALS, which is a project I ran through Johns Hopkins, a nationwide project, is enormous. That project alone, 1,000 patients, which is not a lot, but the data depth is enormous. 6 billion data points per patient, longitudinal data, proteome data, RNA data, whole genome data, about several petabytes worth of data, just that segment of data. And with this prize, there'll be data support. There'll be teams available for those interested in working with the data. So they'll have access to online secure platforms to utilize the data. And the future is not only is that data available now, there's going to be future bins of data coming from other nations around the world that will add to this prize opportunity. Trish.
Thanks, Jeff. So that's the data offer. So we're going to be opening for applications on June 25th. And we're interested in two things, really. One, as Jeff was saying, AI power. So we want you guys to seriously consider whether or not you might be interested in applying. The second is disease expertise. So we don't want to just run AI and spit out things that are not relevant. And so there will be a convening period where if you don't have the disease expertise, we will help you connect you with people, particularly through the Johns Hopkins networks and in Europe and Australia and elsewhere, with people who do have that disease expertise, because we suspect that will be important to bring those two together. The prize opens, as I've said, June 25th, and there's a 6-month period. And that 6-month period, we will release some of that data. We will run some data hackathons, but we will also be helping AI specialists connect with disease experts to form those groups. So that's why there's a 6-month period. Then in the first round, there's a discovery stage where 25 teams will be selected. They'll get access to that data. They'll get computational power, and they'll also get $100,000 and a bunch of other stuff, publicity, access to investors, and all that sort of thing. And then following that, we will then whittle down to 10 teams, although we will allow new entrants at that second stage as well. And that will be around building out that evidence base around those proposed therapeutic targets in silico, but also in a lab. It'll be a blended in silico and lab effort. And then the final stage will move into the lab for 2 years with $500,000 and 5 teams. And the winner will be the one that is deemed to have the highest therapeutic potential. So keep an eye out for that. These are our partners. It wouldn't be possible without them. MNDA is the largest foundation in Europe specializing on this disease. But we also have partners in the US, 10,000 Brains Project, Packard Center, Answer ALS, and partners in Australia, Answer ALS. These are all our funding partners. And then data partners, which are really scattered around the world. So it is a global prize. I think the last thing to say is, the slide's missing. Jeff and I will be out and about, so please do come and talk to us outside. The last slide did have various hashtags and things, but if you search Longitude Prize on ALS in Google and on Twitter, you will find us, LinkedIn and so on, you'll find us. So please do that. Yes, thanks very much.
Thank you.